In recent weeks, an interstellar visitor known as 3I/Atlas has captured the imagination of scientists, astronomers, and the public alike. Discovered racing through our solar system from the depths of interstellar space, this object has sparked intense debate, not only because of its unusual physical characteristics, but because of what those characteristics might mean. Is 3I/Atlas merely an ancient comet shaped by billions of years of cosmic travel, or could it represent something far more extraordinary? These questions took center stage during a recent discussion on News Nation Prime, where renowned theoretical physicist Michio Kaku addressed growing speculation surrounding the object. While some have suggested dramatic possibilities, including artificial origins, Kaku offered a far more grounded, yet no less fascinating, scientific explanation. At the heart of the controversy lies the research and public commentary of Avi Loeb, a Harvard professor known for challenging conventional assumptions about interstellar objects. Loeb has pointed to several anomalies in 3I/Atlas that distinguish it sharply from comets previously observed by humanity. Among these are the object's apparent lack of a traditional cometary tail, unexpected chemical signatures, particularly the presence of nickel, and what appears to be an unusual acceleration as it passed near the Sun. For many observers, these traits evoke memories of Oumuamua, the first known interstellar object detected passing through our solar system in 2017. Like 3I/Atlas, Oumuamua defied easy classification, displaying motion and structure that did not align neatly with established comet or asteroid models. That earlier mystery left lingering questions within the scientific community, questions that now resurface with this new visitor. However, according to Michio Kaku, the unusual nature of 3I/Atlas does not require extraordinary explanations. Instead, he argues, the key lies in the object's age. Most comets observed within our solar system are thought to be between 3 and 4 billion years old, remnants of the early formation of planets orbiting our Sun. But 3I/Atlas is different. As an interstellar object, it did not originate here. Based on its trajectory and composition, Kaku suggests it may be as old as 7 billion years, predating the formation of our solar system itself. This is a very old object, Kaku explained. That's why, for example, the nickel content of the comet is off-scale. Its chemical composition is not what an ordinary comet should be. Over billions of years wandering between star systems, such an object would have been exposed to vastly different cosmic environments. It could have passed through stellar nurseries, supernova debris fields, dense molecular clouds, and radiation-rich regions of deep space. Each encounter would subtly alter its surface chemistry, embedding elements and gases not typically found in younger, solar system-bound comets. From this perspective, the presence of nickel, while unusual, is not mysterious. Rather, it is the natural consequence of time on a cosmic scale. Kaku further notes that the absence of a traditional tail may also be explained by age. Younger comets often display dramatic tails when approaching the Sun, caused by the sublimation of volatile ices. But an object that has already lost much of its volatile material over billions of years may simply lack the ingredients necessary to produce such a display. In other words, 3I/Atlas may not be strange because it is artificial, but because it is ancient beyond comparison. Still, the debate does not end there. One of the most discussed observations is the apparent increase in velocity as the object passed near the Sun. Avi Loeb has suggested that this acceleration could be consistent with propulsion, even floating the possibility, carefully framed, that it might indicate an engineered origin. Kaku strongly disagrees. While acknowledging that the acceleration is unusual, he cautions against jumping to conclusions. Speculation is fine, Kaku said, but you have to quantify it. You have to say, what is the level of confidence on this speculation? Is it 100%? Is it 1%? According to Kaku, there are multiple natural explanations that could account for the observed speed change. One possibility is outgassing, where material beneath the surface heats and escapes, acting like a natural thruster. Another is fragmentation, in which a piece of the comet breaks off, subtly altering its momentum. These mechanisms have been observed before in comets within our own solar system. There could be reasons that explain why there's a sudden spurt in velocity, Kaku emphasized. That's not a smoking gun. This distinction between anomaly and evidence is crucial. Science advances by questioning assumptions, but it also demands rigorous standards of proof. Without precise measurements, reproducible data, and statistical confidence, extraordinary claims remain speculation. That is why both Kaku and Loeb agree on at least one important point: data transparency. The object is currently being monitored by NASA, which reportedly captured high-resolution images of 3I/Atlas on October 2nd. NASA has also stated that the comet poses no threat to Earth and is expected to make its closest approach around December 19th before continuing its journey out of the solar system. Loeb has publicly urged NASA to release its most recent data so independent scientists can analyze it. Kaku supports this call, not because he believes the object is artificial, but because open data is essential for scientific credibility and public trust. Otherwise, Kaku warned, you panic the public, and the public wants to know the truth. This concern highlights a broader issue in modern science communication. In an age of instant headlines and viral speculation, nuanced scientific discussion can easily be overshadowed by sensational interpretations. Interstellar objects, by their nature, feel alien and unsettling. But unfamiliar does not mean artificial. Indeed, the true wonder of 3I/Atlas may lie not in hypothetical engines or hidden technology, but in the story it tells about the universe itself. This object is a messenger from another star system, carrying with it a record of environments humanity has never directly observed. It offers scientists a rare opportunity to study material formed under conditions vastly different from those that shaped our own planetary neighborhood. From this standpoint, 3I/Atlas is extraordinary, not because it might be built, but because it was not. As it continues its brief passage through our cosmic backyard, astronomers will gather as much data as possible before it disappears forever into interstellar space. Each measurement, its composition, trajectory, reflectivity, and motion, adds another piece to the puzzle of how planetary systems form and evolve across the galaxy. In the end, Michio Kaku's position is clear. While the universe may indeed harbor intelligent life, and while future discoveries may one day confirm artificial objects beyond Earth, 3I/Atlas does not currently meet that threshold. For now, it remains what science so often reveals when mystery gives way to understanding: an ancient traveler shaped by time, carrying the quiet complexity of a universe far older and richer than our imaginations. And sometimes, that truth is more profound than fiction.